One of the common techniques for constructing a list would be to use a for loop and iterate through items, and at every step or at every iteration you would append the result of whatever you had to do with those items into the new list. In the example you see on the screen, we have a list called X. We're looping through from 0 to 9, that's the result of range 10, and we're going to append those values into the X list, and then we're going to print them out. And as you can see here, we have the values 0 through 9. A different kind of construct known as list comprehension expressions will allow us to do a very similar operation with fewer lines of code. So this very same list can be constructed using this syntax instead. As you can see, we get the same results. So what is on the screen here is a list comprehension. You know it's a list comprehension because it's an expression contained within square brackets. The square brackets are a not so subtle reminder that the result of this operation will be a list. So it's a way to build a new list by running a given expression on each item in a sequence, one at a time from left to right, in this case from 0 to 9. So let's look at the syntax of this particular construct. And here we have it. I put it in a separate comment here so you can see the basics. So the result is going to be some list. And you set it equal to, and the square brackets are the requirement for a list comprehension. And then for every item, for every X in the thing we're iterating through, this is the result. Typically it's going to be, if this is the variable X, literally, it'll be X for X. But it doesn't mean we have to just use X as it is. We can actually be a little more sophisticated and do more complex things with this result. So let's take a look at another example where we will create a list of squares. When I mean squares, I mean the squares of numbers. So we can again do a for loop for X in range 10 one more time. And then inside there we could say squares dot append, and then we'll do X squared. And then we'll print squares. Now you can see, instead of appending 0 through 9, we've appended their squares, 0, 1, 4, 9, etc., till 9 squared, which is 81. Again, we could do the very same thing using a list comprehension, and I'm going to copy that syntax again to show you how we would substitute what we had before to get the result that we see here where we were doing the squares. So I will say squares, and notice here I don't have to declare it first. I just say squares because the result of this operation is a list. So I don't actually have to declare squares as a list before assigning it a list. Now instead of I, what I'm going to use is the X, just like what we had here in our for loop. We're using X for our variable. And we are still going to do the for loop the same way. It's for X in range 10. So that's the exact same for loop that you see here. The difference, however, is instead of just returning X for every item in the comprehension, I'm going to return X squared. So for every X, we are performing this action and assigning it to the next value that is returned in the list. So instead of printing X, we're going to print squares. And then we'll run this. And you can see we get the very same results. So for the most part, list comprehensions can be as sophisticated as anything you put inside of a for loop. However, it can get to the point where it's next to impossible to read. So one of the things that you want to use as far as your judgment is concerned is whether or not the comprehension is going to be maintainable in the future. If you write a comprehension that does a lot of sophisticated things and it runs fast, it does everything you need, and it's all in one line, that's fantastic unless you can't maintain the code. And some of the examples we'll go through cross that boundary where it may not be useful to use the comprehension syntax at all. Now, as far as the iterable item here, which we're typically using this range function to calculate, we can use any other iterable item in its place. It could be a string, it could be a list of other numbers. Let's say I had a list I generate as such, and I'll just call it list. We can again say squares is equal to x squared for x in list. So it doesn't have to be a range function. And I'll print the list and I'll print squares again. So we'll have 1, 2, 3, 4, and then we'll have 1, 4, 9, 16. And we could do the same thing with cubed or to the fourth. It doesn't matter. Whatever we want to do to x, we can do it right here. But what if our list is a list of strings instead? And let's say we want to extract the first letter from each word in this list. Well, then we could create a letters list. And remember, the result of a comprehension is always a list, at least for a list comprehension. We could say for return word 0 for every word in words. And so what it's doing is it's iterating through words one at a time, first, second, third, fourth value. Each time it's saying, here's the given word, get the first letter from that word, and that's what's appended to the letters list. And there you have it. We have the first letters, T, I, A, and T. Now clearly if you had a blank string, you'd want to handle that appropriately, because getting the first letter of a blank string this way would necessarily cause an exception to let you know you walked off the end. But what if we want to do something a little more sophisticated, where we want to return the same list of words, but this time we want to capitalize the first letter of each word? Well, let's go ahead and just copy everything we had before. So we have our words, and then instead of letters, just let's call this capitalized, so we keep them distinct. And we are still going to return word 0, but instead of just returning it as is, let's convert that to upper. And if we were to print this now, you can see we have the first part done. So now the first letter of each word is capitalized, but then we need to also return the rest of the letters for each word. And to do that, we could append to the result word, and then we'll say 1 colon. That's saying get me everything from index 1 of that word, or character 1. So the H for this, the S for is, nothing for A, and the starts at the E for test. I want to return all of that, and let's force these to be lower. So we take the first letter, make it upper, and all remaining letters we make it lower. And you can see this is a test where the first letters are all capitalized. Now we can take this to a crazy destination here and make a comprehension that is really sophisticated but virtually next to impossible to maintain. So let's go ahead and create a new list of words. This time it's going to be the words in a book title. And then just scraping the internet a little bit, I found a list of words that you should ignore for capitalization rules. Okay, and I have them alphabetized here. Hopefully I don't have any duplicates. It doesn't matter, but I'm trying to keep things in the singular form here, so we only have one each. So the ones you probably are familiar with, don't capitalize the letter A, the article word A, and, as, at. And this is going to be a trivial example. There are rules that say sometimes these would be capitalized based on how they're used. But let's just assume these are the words that are never capitalized. And we're going to extend the previous example. So I'll say capitalized, or better yet, let's call it title. And we'll set it equal to, well, we have to get the first letter of every word and make that capitals, and every other letter should be lowercase. So I'm going to copy that first part because we know that's going to happen for every word. However, we always want to make sure that the first word is capitalized, the last word is always capitalized. But anytime we run into one of these words that are in the ignore list, we never want those capitalized except for those conditions, if it's the first or the last word. Every other word should always be capitalized. So here we can start to use our ternary operator. So we can say, do this chunk of code. And you know what? I'm going to put it in parentheses just to make it a little clearer. So we do that chunk of code if index equals 0. And you might be asking yourself, what index? Well, I'll show you index in just a minute here. Or index is equal to the len of words minus 1. Or word.lower not in ignore. Okay, so at some point we're going to have an index variable that's going to indicate what word we're on in the list of words. And then we are going to say only convert the first word to upper lowercase mixed if we're on the first word, the last word, or the word is not in the ignore set. Else, what we're going to do is we're going to just use word.lower for, remember this is the other part of the ternary operator, so when this is true, we do the part right before the if. If it's false, we do the part after the else. Now here, we're going to use the enumerate function to iterate through words. So before we're just saying for something in something. But now we want to get the tuple, index and word, and to get that, so it gives us both the position of the word and the word itself from the words list. Okay, so that right there, like I said, this might get to the point where it's unmaintainable because it is a very complex comprehension. And then assuming I didn't miss any parentheses or anything else, we should be able to print title and see the results. You can see 2 is capitalized. It normally shouldn't be. Remember, 2 is in the list right here. Shouldn't be capitalized, should be ignored, except it is the first word. Kill is, A is not, because it is one of those ignore words, and it's not the beginning or end. And then mockingbird is first letter capitalized. And we could really have some fun with this just to prove it's doing the work we're asking it to by, let's say, making this capital T-O and make the I-L capitalized. We'll make the A capital, maybe K-I capital, and then let's say IRD. So we have a really scrambled looking list of words. And it looks like I forgot a letter here. There we go. But it's still looking correct after it runs through the list comprehension. Again, this is a really crazy comprehension and probably not something you would do in practice, but I just wanted to show you how powerful this feature can actually be. Now there's another way to do conditionals in our code. Let's say, for instance, we want to create a list of random numbers. So I'm going to use the randint function out of the random library, which we're going to have to import. So we're just going to get a list of 10 random numbers. And to do this, I'm going to have to import. So from random, I'll have to import randint. Make sure I run that line, otherwise I won't be able to use the function. So randint is going to give me a value between 1 and essentially 99 here. And we're going to get a random number 10 times. So we're not actually using x at all in this example. It's just there as an iterator variable. Let's go ahead and see what that results in. So we do have random numbers. If I run it again, they should be a completely different set of numbers. Now let's say I want to create a list based on this rands list, but only keep even numbers. So let's create an evens list. Then we'll say list comprehension. We start with the brackets because that way we know it's a comprehension. And we're going to say we want to keep the x or return x for x in rands. But you're saying to yourself, this just returns everything. So right now, if I print evens, it should be the same as rands. In fact, it is. What I need to change is only get the numbers from rands that are even. Well, the change in the syntax is going to be adding a conditional after the for in expression. I'll say if x%2 equals 0. So this right here uses the modulo operator to say if there is no remainder when dividing by 2, we're assuming that's an even value, which it would be. So now it's saying get me all the x's in rands only if x divided by 2 yields no remainder. Now run it again, and you can see I only have the even numbers. If I change this to a 1 instead of a 0, that would only get me the odds. So I could do that. So I have evens. Now we could say odds is equal to the same thing, except when the modulus returns 1, those are the values we wish to keep. And as you notice, the results are changing every time we run this because I'm getting a new list of random numbers every time. So you can see we have 6 evens this time and 4 odds. Run it again. Once again, 6 evens, 4 odds. This time 4 evens, 6 odds. We can also join if statements together so that we can have essentially AND conditions. So let's go ahead and create another list. We'll call it numbers, and we'll set it equal to a list comprehension, x for x in range. One more time, 100. So we're going to loop through 100. And then we want to say only if x%3 equals 0. So that would give us only the numbers divisible by 3. So if we print numbers, now these are all the numbers evenly divisible by 3. What if we wanted to restrict it further to say it must be divisible by 3 and it must be divisible by 5? So then we could add another if statement, say x%5 equals 0. Now it's only going to give us the numbers essentially divisible by 15 evenly, because the x must be divisible by 3 and 5 evenly. And you might be asking yourself, couldn't I just write it like this? If x%3 is 0 and x%5 is 0? Certainly you could. Okay? Where this comes in handy, however, is if you end up with multiple variables, like you have both an x and a y that you might be using as conditions. So there is no particular reason why you have to use the nested ifs like this. If it makes more sense to use the and actually join them together in a single Boolean expression, by all means. If it works for the loop, do whichever is going to be easier for you to understand and which actually solves your problem. And just like we can have nested if statements, we can also have nested fors. So if I were to create two lists, one containing the letters A, B, and C, and then I'll create another list, this will be B, and it'll be 1, 2, and 3. If I wanted to create a final list that is a cross combination of all the letter and number combinations, so I want to see A1, A2, A3, B1, B2, B3, and C1, C2, C3. If I wanted to generate that list, I could easily use a comprehension to do that. So I'll say C is equal to A plus B. These are just arbitrary variables I'm going to use. And it'll be for A in A. And remember, Python is case sensitive, so this is legal. Maybe a little hard to understand that this A and this A are different. Just essentially our set, or our letters that we have in the list here, that's the capital A. And we're saying for every letter in A, or every string that's in the A list, we're going to take it and append it to B, which, as you may have guessed, is going to be another for expression. So we'll say for little b in big B, and let's print C. As you can see, there are 9 results. It's essentially the length of A times the length of B. And so you see A1, A2, A3, B1, B2, B3, and C1, C2, and C3. So it gives us the combination of all the different values. It is essentially a nested for loop. So now that you know about list comprehensions, you should probably use them where they're appropriate. Just like any other code, you could end up overusing a particular technique that it just makes the code harder to read and harder to maintain. And yes, like I showed you up here in this example where we're capitalizing a title, this may be served better by creating a formal function to do the work, because this is really complex, and anybody who's a novice to Python, and even an expert, might look at this and go, why on earth would they write a comprehension that complex? So it really depends on what you're trying to accomplish, but typically use this tool only when it makes sense. When you're going to do a simple translation from one list to another, where you need to filter from there. But there are other techniques we can use as well. There's mapping, filtering, reducing, and those are techniques that we'll do in a different demo. But comprehensions also work with dictionaries and sets, again, which we'll cover in their own specific demos.